Okay, so more practice with conic sections. We're going to look at hyperbolas today, though, in a little bit. And then you guys will have the basics for all conic sections after that. Okay, so let's review, though. We've got this equation. It's got x and y's in it, but only one of the values is being squared, which means we know that this is going to be a parabola. And then in order to get everything working out, what we want to do is we want to get everything with a y, because y is being squared on one side, everything else on the other. So I'm going to move that negative 8x. I'm also going to move that constant to the left, and that leaves us with 2y squared minus 12y on the right-hand side. And then we're going to go ahead and we are going to complete the square. Now, there's one thing we could do before, or we could do it after. It really doesn't matter how it all works out. But I think let's do it in this step. I'm going to divide everything by 2 because everything is divisible by 2. We've got a bunch of even numbers here. So when I divide everything by 2, it's going to make our lives a little bit easier on the right-hand side. We see the coefficient of y squared becomes 1, and then we just worry about completing the square. So we take negative 6, we divide it by 2, and we square that. That's going to be a 9. So that also means we need to add 9 on the other side as well. Okay, so now we've got this. We have got 4x plus 4 on the left, and then we've got y minus 3 squared on the right. The last step I need to do is get x by itself as well. Remember, x has to also have a coefficient of 1, and I'm going to do that by taking a 4 out of everything on the left. And then the very last step is to divide everything by 4. Now, the way that I'm going to represent that as a stretch is as 1/4 in front of the y minus 3 squared. Okay, so that is our vertex form of this parabola. The vertex then, hk, is the number with x, -1, and then the number with y is 3. That gives us a vertex of -1, 3. Now, if we think about the way that this parabola, is facing, again, we've got a case where y is the term being squared, which means it either opens left or right. Because the stretch is positive 1/4, we have a parabola opening up to the right. And this is the vertex -1, 3, which would make the axis of symmetry, that horizontal line, y is equal to 3. Okay, so let's plot this. I know that this parabola opens up to the right, which means that I am going to plot the vertex on the left-hand side. And then I'm going to draw the axes that make that true. So what axis would make this -1, 3? Well, a y-axis there and an x-axis here. Okay, again, I'm going to use the shortcut for graphing a parabola. Make a t-table if you need. Standard right facing would move up 1, right 1, but we're going up 1, right 1/4 because of that stretch. Standard right facing parabola would move up 2, right 4. This time we're going up 2, right 1 because of the stretch, and down 2, right 1. We'd go up 3, right 9. This time we're going up 3, right 9/4. I'm not really going to graph that one, so let's try 4. If we go up 4, we go right 16, but we have a stretch of 1/4, so we're going up 4, right 4. And that one is going to give us a little bit better of an idea of what the curve is going to look like here. And then I'm going to go down 4, right 4 as well. Okay, 5 points is all you need on your homework to graph a parabola, but I did a couple of more just to give us a better curve there. And then I'm going to drop in that axis of symmetry, and we've got our parabola done. All right, moving on to the next example here. We're going to graph a hyperbola today. It's something that we didn't do on the last lecture. So here's how we graph hyperbolas. We're going to graph the center first. Then from the center, we're going to graph the asymptotes. Hyperbolas follow asymptotes. We'll see how to get those lines from the equation. Hyperbola is by far the most difficult conic section to graph. And then we'll graph the 2 vertices, and then we're going to sketch in the rest. So the sketch is just going to be from the vertices following the asymptotes, and really that's kind of how it goes. We are going to have different facing hyperbolas depending on whether or not the x or y values are positive. So when the x value is positive, we have a hyperbola that opens left and right. So I like to think of it like this. When x is positive, the hyperbola is going to make something like an X shape. When y is positive, that means we're going to open up and down. So we'll have like a Y shape in our hyperbola if y is positive. Okay, so let's take a look. Number 2, we have the equation of a hyperbola. We know it's a hyperbola because x and y are both squared, but one is positive and one is negative. So before we can do anything, we've got to complete the square for both x and y, and then we'll go from there. All right, so I'm going to move everything with an x next to each other, and then I'm going to move everything with a y next to each other. And then everything else is going to go on the other side. So I'm going to get rid of that constant 28 by subtracting it. Okay, so we divide everything by 16, which is the bigger of the two coefficients there in front of x and y. And then what happens is we get x minus 2 squared over 16 is 1. So I'm just going to write as 1 squared for magnification form purposes. And then minus y plus 3 squared over, now 4 over 16 is 1 over 4. I'm going to re-represent that as 2 squared in the bottom. This is equal to 0. So that's magnification form there of this hyperbola. It's degenerate because it's equal to 0. And now the last thing we can do is just figure out what the two asymptotes are. So the center of this hyperbola is 2, negative 3, comes from the numbers with x and y. X minus 2 gets us positive 2, and y plus 3 gets us negative 3 for the center. And that's pretty much where we're going to start. So I'm going to put the center there. And I'm going to drop the axes that make that center true to 2, negative 3. So that makes that 2. That makes that negative 3. And then because this is degenerate, we can't actually graph the curve. So there's no vertices, but we are going to sketch the asymptotes that we would follow if we were graphing the full curve. And then we'll do a full curve example. So in order to find the asymptotes are always lines. Okay? Now, with a line, we just need a slope. So here's how we find the slope. Remember, slope is always change in y over change in x. Think back to algebra 1. Okay, look at the number under y. It's 2. Look at the number under x. It's 1. So the slopes of our asymptotes are positive 2 and negative 2. That's how we find the slopes. Okay, change in y over change in x, always true. Go from the center, graph a line with a slope of 2. So up 2, right 1, up 2 over 1, up 2 over 1. That's our line with a slope of positive 2, and then graph from the center again a line with a slope of negative 2. So down 2, like that. Okay, from the center. And then just sketch the asymptotes. And that's all we can do for degenerate hyperbola. So degenerate circle or degenerate ellipse, you graph the center, that's it. It's a single point. For degenerate hyperbola, we graph the asymptotes. And then there's no degenerate parabola that we're going to look at. Okay, the equations of these asymptotes then. We've got two equations. If I'm looking at the equation of the negative slope, I see that the y-intercept here is positive 1. So negative 2x plus 1. And then the equation with the negative slope, we see the y-intercept here. 1, 2, 3, 4, 5, 6, 7, negative 7. So that was 2x minus 7. Right? Positive slope of 2, and then the y-intercept was negative 7. There'll be a couple trickier ones where you guys are going to actually have to find the intercept. It might be a fraction, but that's kind of how we do it. All right, one more example with a hyperbola, then we're done. You guys are going to work on homework. Okay, Number 3, last one I'm going to work through with you guys. This is a hyperbola. This is a real hyperbola, not a degenerate, and we'll see that as we work through the equation here. Okay, so first thing let's do is let's complete the square. So I'm going to get everything with an x together, and then everything with a y together. And then I'm going to move that constant over to the right-hand side. I'm going to factor out of 4 for the x's and complete the square. And I'm going to factor a -9 out of the y's and complete the square. All right, now remember, technically we are adding 4 times 1 and then also -9 times 25, which is -225. Okay, so what this comes to be when I factor everything, make it look nice, is x plus 1 squared and then -9 times y minus 5 squared is equal to -36. Okay, rules for conics tell us we need magnification form, which means we need the right side to be 1. So in order to do that, we're just going to divide everything by -36. Okay, and then what we end up with is we end up with x plus 1 squared over 4 over -36, that's just -9, plus, because it's -9 over -36, y minus 5 squared, and then 9 over 36 is 1 over 4. That's equal to 1. I did one more step to get it to magnification form. We want to make sure that we represent the bottom, the denominators, as perfect squares. So I'm going to pull the negative out to the front, and then I'm going to represent 9 as 3 squared. And then I'm going to represent 4 as 2 squared. Okay, so there we go. Magnification form of our hyperbola. Let's figure out what we need in order to graph. So the center here is going to be -1, 5. That comes from looking at what's inside with x and what's inside with y. We take the opposite sign. We'll find those equations of the asymptotes in a minute, and then we'll talk about the vertices after that. Now, I do want to discuss really quickly what this hyperbola is going to look like. Which way is it going to open up? So the y term is positive here, which means the rule says this: hyperbolas that have an equation where y is positive is going to open up and down. So eventually, when we sketch and everything, the curves are going to go up and down. Okay, let's start though with the center, always helpful. I'm going to plot the center here. What makes that the center? I'm going to drop the axes, -1 and then 5. Okay, and then the next thing we're going to do is graph the asymptotes, because the asymptotes are going to help us sketch the curve, essentially. So changing y over changing x for the slope of a line. The number under y is 2. The number under x is 3, which means our slopes are plus or minus 2/3. So from the center, you're going to go up 2, right 3, up 2, right 3, and then same going down, down 2, left 3, 1, 2, 3. All right, and then from the center again, to get that negative slope, we're going to go up 2, left 3. And then I'm going to sketch in the asymptote, the lines there. Okay, so those are our asymptotes. Now, we know a couple of things. Unfortunately, if we look at the y intercepts on those asymptotes, they're not in nice places. They don't hit good numbers. So think back to algebra. You've got to use your knowledge of writing the equation of a line to get the two asymptotes. So if we use point slope form and we use the center as our point, y minus 5 is equal to m times x minus negative 1. That's one line. And then the other is just going to use the negative slope. So when I simplify those things in order to solve for y, we get 2/3 x plus 17/3, and then we get negative 2/3 x plus 13/3. So on your homework, I want it in terms of y and y alone. So just simplify those using point slope form or however you like to write the equation of a line from algebra. All right, last thing is the vertices so that we can actually sketch the graph of this hyperbola. So we know that the hyperbola is opening up and down. So we take a look at the positive term. Y is positive. So we look at the positive term. The denominator of the positive term is 2. Start at the center, move up 2, and move down 2. Those are the vertices. Okay, so our vertices, -1, 7, and -1, 3. All that's left is just to sketch the curve. The curve is going to follow the asymptote like this. So it's not quite parabolic. It's going to be a lot flatter than a parabola. They're not the same. They don't follow the same curve. Parabolas don't follow asymptotes like that. But that is how we graph a hyperbola. So a little bit trickier when you're doing your homework. It's going to look like this. You guys are going to follow those directions for full credit. All right, email me if you guys have questions.